So we're going to look at the ternary operation. And so I'm going to start off by declaring a floating point number called temperature. We're going to ask the user for temperature, and we're going to CIN it into this temperature variable. And then what we're going to do is we're also going to define a variable that's a string called air conditioner, which we'll just use to put the state of the air conditioner. And we're going to say if temperature is greater than 80, air conditioner will equal on, and then we'll use the else. Off, and then we'll do down here is we'll see out. We'll put a backslash and do to add a carriage return. And it'll say either the air conditioner is on or the air conditioner is off. So go ahead and type that in, and then we'll run it. And let me know when you have it typed in.
I have it all typed in.
I'm usually going to use Control F5 and so if I put 70, what do we expect to have happen? Will the air conditioner be on or off?
Should be on.
It's off. So if 70 is greater than 80, this would be false. So we'll do the else condition, which will make it off. Does that make sense?
Yes.
So, and then if I run it again, I put 90, what do we expect? On, right? And then often what you want to do is when you're testing is test the edge case. In this case, the edge case would be 80. What would we expect at 80? On or off?
Should be on.
Yeah, well, so is 80 greater than 80? So this is going to go into temperature, and then temperature, look at this line, 80 greater than 80, and evaluate that in your mind.
$80 is not greater than 80, so it would actually be off.
So when you have, and so it says we have, we have two branches here. So when we test this area of the code, we kind of have to do 2, maybe 3 tests in this case. And it's useful to look at the edge condition because sometimes that could matter with the spec. So you would look at and see, was the requirement that at 80 the air conditioner come on, or is it at you know, when it was greater than 80, i.e. at 80 point something something something, it would come on. So once we have this, this is one way of doing this. Now there's a shortcut for this. I'm going to take this code and hit Control K and hit Control C. Control K and Control C is a way of commenting everything out really fast. I'll write that in the. So that's the comment, and Control K and Control U is uncomment. And so that's could be kind of useful. Control K, Control U, uncomment, Control K, Control C, comment out. I'm going to do that and then hide this so that I can come back through here and show you how a ternary operator is done. So with the ternary operator, we have some variable which we want to assign a value, and it's going to get one of 2 values based on this. And so the first thing we write, so ternary, let me put the format here, is syntax is variable equals, and then a conditional. And then a question mark, and then true result, colon, false result. I'll just put this part because so it fits. So we have conditional expression, a question mark, and then what if this conditional is true, what we want the true to be, and then if this condition is false, we want the false result to be. So in this case, we would to write that what we had before, which was up here, as a ternary, what we would say is first we put in the conditional expression, which is this part right here. And then we put a question mark, and then if it's true, we want on. So if this expression is true, we want on. And if it's false, we put after the colon, which is off. So all this code, these 8 lines, gets shortened up to 1 line of code, kind of. Does that make sense? This condition gets placed here. Then we put a question mark. If that's true, we want this value to go into here. Otherwise, you want this value to go into here.
Makes sense.
What do you note that's kind of different about this? No, you couldn't use this really to kind of as a big branching statement because it's really an expression that returns a value, right? All this returns a string. So it's limited in what you can do with it, but sometimes it can be used to kind of clean up your code and make it a little bit, a little bit less wordy. So, all that cleans up to that. And if you run this, it should work the same way. And so here we put in 70. 70 is not greater than 80. So we don't do the true one. We do the false one. Off goes into air conditioner, and then it says the air conditioner is off. Does that make sense?
Yes.
Yes.
So that's one format of that's another. So that's the second format of a conditional. I'm going to comment this one out too. And then comment this out. Actually, I'm going to do this. I'm just going to delete it so I can start fresh. Another format that we can use is called a switch statement. So I'm going to make a character user input. And then I'm going to see out, and this is going to look very much like what we did with that other demo. Please enter A, B, or C, and see it into user input. So we're going to bring this in as a char, not as a string. And the reason is because a switch statement can only work with either a number, or either an integer or a char. A char is actually an integral type, so it's kind of synonymous with an int. So we're going to do, with the switch statement, what you do is you say switch, and you say user inputs. And this can be any variable as long as it's either an int or a char. And then what you do is you list your cases. So we say case A, note that that's a single quote because it's a char. And then we're going to put break. And each of our cases is going to look like this. So that's the form of the case or the switch statement. I'll let you finish typing that in, and then we'll try running it. Let me know when you have it typed.
All done.
Go for it.
Okay, so got A, B, or C, and then I'll hit F5. Oh, I guess I hit, I put it in run in debug mode. That's okay. We might as well run it that way. Just see it executes. So I'll put B in, and then I'll hit F10. So it steps through. And you'll notice it skipped over A. So the switch went directly to B. It now outputs the output. It's here, the C out. And then notice what happens with the break. The break skips everything else out. And then it continues on. So this is very similar to what we did before. What do you suppose happens if we don't have the break statements? Well, we can find out just by taking out the break statements. So let this terminate up, and I'm going to temporarily comment out these break statements. And then I'll run it in, I'll run it in debug mode. And so I'll put B in again. So here we are at the switch statement. If I hit F10, we're here. Then I'll hit F10 again. Notice that we get you entered B. But now notice that we are actually sitting at the C out as well. So hit F10 again. We then get you entered C, and then we get down to here and we get everything else. So with a switch statement, it's critical that you put the breaks in. That make sense?
Yeah.
Now you can sometimes by design use that. Like if you had it where you wanted everything to be kind of collected and all run, if and kind of if you wanted it to fall through is what it kind of saying, then you could set that up. But generally, for the most part, switch statements, you have breaks in them. Now, another thing you could do is you can do this. You can combine up and put multiple cases associated with, and it's kind of an extension of that fall through principle, really, is what's going on here. I'm going to put lowercase characters as well as the uppercase characters and run this, Control F5. And now what I can do is I can put in, say, lowercase b, and it'll catch it and run with it. Really what's happening is it's just falling. We're just setting up for so it'll fall through. Make sense?
Yes.
Okay, so let's go on to loops. Wrong language. So loop control structures are useful because one of the primary purpose of computers is to not have to repeat things over and over again. We let the computer do it. And so a loop enables a program to repeat statements. And there's in C++, we have three structures for loops. We have a for loop, a while loop, and a do while loop. You're going to find that actually the conditional statements and the loop statements are often pretty identical or very close in almost all computer languages. So once you learn them from here, the knowledge doesn't change that much for different languages. And so C++ languages have either a loop index, a counter variable, or something, or a stopping variable that you use to stop execution of the loop. Otherwise, you get an infinite loop. And usually there's three things that happen with our loops. We need to initially assign some value to our loop counter or stopping variable. We need to check a condition, basically using a logical expression, just like an if statement, on that variable, and then something that alters that index or counter or variable so that it will eventually stop the loop from running. So the first loop we're going to look at is a for loop. And basically, a for loop is useful when you know how many times something's going to run. So it's kind of like you could say run 6 times, run 5 times, run 1,000 times, and it will repeat everything. And in the for loop, the format is you have initialization, a test condition, an update statement, and then inside, then you have your block of code, which will be iterated multiple times. Now note that all these things can be nested. So you can have if statements in here, you can have other loop statements in here, you can have just regular statements in here. And so, the structure can all be plug and played together to kind of work. We can represent using a flowchart, a loop like this. So here we see that we're initializing a loop variable called I to 0. And as long as I is less than 50, we're going to keep looping. So if it's less than 50, then we're going to output hello world, come back around, increment I, and then check it against 50 again. So the first iteration, I will be 0. 0 is indeed less than 50. So we print hello world. I now becomes 1 because we plus it. That adds 1 to I. Then we check I against 50. Is 1 less than 50? Yes. And then we just keep looping around. What would happen if I got rid of this statement right here? Oh, sorry. This plus I part.
It would just be a continuous loop because it'll always be under 50.
Right. So it's critical that when you look at you're building your loop, that there's something that will make the conditional false. Once it becomes false, it exits out, and then it does the last thing. What this looks like with the syntax is here. Int I, this initializes a variable, and then, or declares a variable, and then here inside, we're initializing it to 0, putting in our condition. We then execute this one, if this is true, we execute a condition, then it does this plus I, then it goes back and checks the condition again and just keeps doing this loop. When it's done, we'll get our goodbye. So here's what this looks like. If we're running this, we say for I equals 0, then we check the condition, then we go to cout, and right down here, we're outputting, we're putting what the variable of the 0 of the value is, and then we're outputting the result. This is kind of like a PowerPoint version of paper tracing. If you're not really comfortable with for loops or if conditions or programs in general, it's not a bad idea to grab some of these sample programs from the book and take 2 sheets of paper, have one be variables, have one be output, and then go line by line through the program and write down what the variables are getting set and changed to as you go and what the output is. If you do that a few times, loops and conditionals become very easy to visualize and understand. If you're kind of just writing it and it just seems like magic, you probably need to do something like that until you can actually walk through this entire code and and do in your mind. If you're not there yet, just take the program and take 2 sheets of paper. When I first started learning how to code, that's how I learned how to code. I didn't have a computer at home. So what I did is I wrote out my program, and then I give myself a little bit of time, then go back and I would paper compile it, and in order to be able to visualize it. And so today I can look at a piece of code and I can visualize the variables, and step by step, piece by piece. So here we can see that I start off as 0. 0 is less than 50. We get the hello world. It comes back around. Now it does the plus plus I part. And then I is now 1. And the question is, why 1 less than 50? So 1 is less than 50. This evaluates a true. That means we're going to do another one. We display another hello world. We zip back around, we get to the plus plus I, and now that becomes 2. And then again, we're going to check the condition. That 2 is still less than 50, so that's true. We do another hello world, and it loops back around. We're not going to do this 50 times. It'd be fun, but I think that gives everyone an idea. Does that make sense?
Yes.
Have you all seen other languages with loops before?
Yeah, I've used it with Python and C#.
Yeah. Yeah, so I'm going to go through this stuff kind of slow anyway because I'm recording it for other people to view. So hang on if it seems like a little simplistic. And so let's try this. Let's try to write a loop. And I've got this on Socrative right now. Let's write a loop that counts from 0 to 9. Yeah, if you did Python, there's a little bit more syntax in it. This will look very similar to the C# stuff you've done. Okay, so see what we've got. Yeah, so we initialize it to 0. You can do less than or equal to 10. You can also do less than 9, and then we plus plus I or I plus plus. Either one of those will run your loop for you. Conventionally, we tend to do actually these are slightly different. Less than or equal to 10. We'll go to 9. This one will go to 8. So let's see which one we needed to do. Luckily, I have this up. And so equals 0, I is less than equal to 10 plus plus I. Let's try that one. Oops. Computer's so picky. Yeah, so this will go to 0 to 10. What they're looking for is 0 to 9. So you can actually just change that by less than 10, and that will go from 0 to 9. And often what we do is we don't do less than or equals, we do less thans and then put at whatever the larger number is. We're going to see later on how this kind of makes sense when we start working with vectors and lists. But yeah, for the most part, you all got it pretty close. And you understood clearly where things go in here, which is the important part. And the way you check your loops is output the loop variable or something significant and run it and look at the variables. You can also run your loops in debug mode. Of course, you need to set a stop point first. And if you run it in debug mode, it can be kind of useful because as you F10 through it, you'll see it happen one by one. You can look at the value of I down here. Here it's 0. Now you see the gets incremented to 1. It obviously passed in, and you can chase your loops through with the debugging commands. So use debug to understand your code and also maybe some sample code, and chase through the code, and it'll make it make sense. And then while loops. So that's a for loop. And the for loop you use primarily when you know how many times it's going to execute. The while loop is actually more flexible, but it doesn't give you an index variable. So we're going to find that the for loop is often used when we're dealing with arrays and vectors, and when we want to go through a list a particular number of times. But the while loop is used when we want to do things in a little bit more flexible manner. And the while loop very simply is just while condition, and then you have a block of code, and that condition is just like an if statement. In fact, you could think of a while statement. It's basically an if statement that keeps executing the block of code as long as the condition is true. It's very much like an if statement, but an if statement only executes once. A while statement can potentially execute an infinite number of times until that condition becomes false. So what do we have to do inside this block of code if we want this thing to not be an infinite loop?
Break.
Well, you could use a break, and we're going to learn about that later. But it's not so much using a break statement. It's something else that has to do with this condition. What do we have to do in here related to this condition? And I know I'm not giving you a lot here because I'm just giving you a syntax, but what has to happen in here to this condition for this to stop?
Well, it has to become false.
Yes.
So would you give yourself a way to make it false? Like if you press a key or something, or?
Exactly. So what you have to do is anything has to happen in here that at some point makes this condition go from true to false. And so, that means that it just depends on how you want to do that. It could be, you get a user input, and then that input changes the value in here that makes this condition go false. You could have some kind of Boolean out there, and you check some if statement, and if that condition happens, you set the Boolean to false, and that causes this to become false. There's a lot of different ways you can set this up. We're going to actually kind of do the same thing as we did with the for loop, just to kind of understand this initially, and see how this relates to the for loop a little bit. And so here we're going to set a variable called count to 0. And then we're going to say, well, count is less than 50. loop through here, and then output goodbye at the end. And so when it's looping through here, what it's going to do is it's going to output hello world, and then it's going to increment count. So this is going to be this is very similar to the example we showed in the PowerPoint for the for loop, and it would actually run kind of the same way. You can see that there's, inside of it, here's where our conditional is. Instead of having the incrementing happening inside of this, the for loop, this is happening inside the code down here, and our initialization is happening before we get into the loop. But otherwise, this works actually the same way as a for loop, but we're using a while statement. So let's write a while statement that will display the numbers from 10 to -10 in Socrative. Yeah, so let's see what this looks like since we have this open. So I want to go from -10 to 10. So, what I could do is I could, I need a variable of some sort. So I'll say int num is equal to, was it 10 to -10 or -10 to 10? 10 to -10. Goes 10. And then while is greater, I'm going to go greater than, because obviously I need to count down. And then I'm going to say num maybe minus. And so what we're going to do is we're going to subtract 1. And then just to see what's going on, we'll output this cout num. And let's see if that works. So I went from 10 to -9. So what do I need to do? I want to go from 10 to -10 though, right? So how can I fix that?
Change the -10 to -11.
Yeah. So if I do that, then I get down to -10. And that right there, where you write your best guess, you run it, see what happens, and then make a fix. That's not a bad way to do it. Sometimes people will sit there and they'll agonize over their code, and they'll take a long time staring at it. Just run it and then fix it. Make sense?
Yes.
Oh, question? Okay, so and then the final loop type of loop we have is called a do loop. And the only difference between a do loop and a while loop, see, a while loop, you start with the while at the beginning, is the while in a do loop, the evaluation happens at the end. So you put a do at the front, you put curly braces, and then you put your loop statements. And then at the end, you have your while. How many times minimum are the statements inside of this loop going to execute?
Until the while condition becomes true.
Yep. And actually, it will always execute at least once, because the while condition is evaluated after the first initial execution of the code in this block. So this block is done once, and then it evaluates the while statement. So with a regular while loop, it may actually execute no times, because if the while condition is false to begin, it's false to begin with, it may never even execute. With a do loop, you will execute at least one time. And so here's an example of using a do loop to do kind of the same thing again. We're going to execute 50 times. We set the count equal to 0. We see out, our hello world, and we increment count. And then we check count until it's, as long as it's less than 50, we're going to keep running and keep incrementing count, and then it'll stop. So same thing as the while, it's just that the evaluation happens at the end of a cycle rather than at a beginning. And so write a do while statement that does the following. Write a do while statement that displays the numbers from 7 to 1. So yeah, it's going to be very similar to what we did. In fact, we wanted what 7 to 1. So I could take this and we're going to start at 7. And the condition is while it's greater than, I'm going to put 0. And then I'm going to take this while statement, put it at the end. And one thing you may find you forget to put the semicolon at the end, and then we have a do at the front. So now we're going to go from 7 to 1. The condition is greater, while it's greater than 0, keep looping through, and then when it gets to 0, it should stop. And so if I run this one, 6, 5, 4, 3, 2, 1. Make sense?
Yes.
Yeah. So all the while is just all the do while is a while statement with the while at the end rather than the beginning. So let's take a break. Come back at 4:35. Reconvene at 4:35 and spin up some Visual Studio with a project called Loops Demo, and we'll play around with the Loops Demo and some code. So reconvene at 4:35. Okay, I'm back. Can everyone hear me?
Yes.
Let's see. So hopefully everyone started up a new project. I'm just going to continue on with this one. Okay, so we're going to do a more typical use of the while loop. So we're going to make a variable called repeat, and then we're going to ask the user how many times they want to do this. And always make sure you let the user know what format you want the input in. We're going to get the user's input and put it into this variable repeat. And then what we're going to do is we're going to say while repeat is greater than 0. And I'm going to output repeat. And I'm also going to do the decrement operation right in here as well. So go ahead and type that one in. And I'll copy and paste it into the chat window. And let me know when you're ready for me to continue. Cool. So everyone with me?
Yeah.
Okay, so I'm going to build it with Control F5, and if I put 7, hit enter, I get 6543210. Why does it start with 6?
Because you're decreasing the amount before it actually displays the value.
Yeah, so what's happening here is we have a pre-decrement, which means this minus minus operation is going to happen before it evaluates the expression it's in. And so we're going to run this in debug mode. I'm going to put a stop at 15. And I'm going to again put in 7 and hit enter. And my instruction pointer is now right here. I can see repeat is 7, and I expect this whole thing to evaluate. Oh, this is cool. If you hover over it the right way, it's always kind of tough. It'll actually tell you what the overall evaluation is. But 7, I know, is going to be greater than 0. I know it's going to come into here. So I'm going to hit F10. I'm now sitting over the cout. Repeat is 7. When I execute the cout, though, the decrement's going to happen first. So if I hit F10 one time, repeat was decremented before it does the output. Does that make sense?
Yeah.
And if I keep running through this, you can see it'll keep going through. Right now, repeat is right at 1. 1 is still greater than 0, so it does another iteration. Repeat is 1. It's going to decrement before it outputs. So when I do that, I get this 0. It's going to come back around. Repeat is now 0. 0 is not greater than 0, and that's when it ends. It's sometimes useful to look at the termination of a loop just to make sure you understand how it's finishing up. And if I look now, I can see repeat has the value 0. So I'm going to stop that. And then what I'm going to do is I'm going to change my code up a little bit. I'm going to put the minus minus after the repeat. So now this is where it's called a post decrement. That means I'm going to decrement repeat after I execute the statement it's in. And so now if I put 7, and I step through this, repeat is now 7. It's going to do the decrement after it does the cout. So now I get the 7. And as I go through, it goes from 7 down to, and then the question is, where is it going to end? Well, let's see. I'm at 2. I'm decremented down to 2. I come back up. Well, 1's greater, so I should see the 1 display. Right now, it's 0. I come back around, and it's going to stop here, and it's going to stop with it being equal to 1. Does that make sense?
Yes.
So depending on how you set things up, pre-decrement, post-decrement, whatever you're doing, you can change what the outputs are. We can change this up to a do loop just by switching the order here. So this can become, so we could also do it this way. And don't forget your semicolon at the end there. So I'm changing this from a while loop to a do loop, just by putting the while at the end with a semicolon and then putting a do at the beginning. And if I run this one, if I put 7, kind of runs the same way. Even if I changed this to pre-decrement, it's going to run probably the same way as it did before. So that's what, when we have predecrement, it looked the same. So they look the same, but here's a difference. I'm going to run this again. And I'm going to put in 0. Notice that it runs at least once. Whereas if I had it like this, you don't have to follow me on this one. I'm just going to if I have it in the while mode and I put in 0, you can see it actually won't run at all. So that's a primary difference between a while and a do while. Do those differences make sense?
Yes.
So a lot of times what we use our do while for is what's, and you're going to do this a lot, is we make something called a do another loop. So I'm going to output, this is an iteration, and put it in repeat. So usually what it is here we do something. And then down here, and what I'm going to do is see out. We're going to ask the user if they want another. I know in the one I did, I said yes, but generally put YN to make it easier on the user. And because we need to use getLine, we'll have to include string. So I'll let you type that one in, and then we'll try it out. Okay, so I'm going to hit Control F5, and I'm going to hit yes. And I'm going to hit yes. And as long as I keep hitting Y, it's going to go around and do another. And in here, all I'm doing is I'm just counting up the number of iterations I did. And when I click no, it's done. So for most of your programs from here on out, you're going to have a do another loop. And rather than doing this thing, your standard do another looks kind of like this. I'm going to see out, do something. And often when I start a program, it really is just this. So you could even save this code in a text and just copy and paste it in there as a start of most of your programs, because most of the time you want to give the user to be able to do another. So I'm usually doing this, testing my do another, knowing that that works, and then I start writing code in here. Does that make sense?
Yeah.
And there's little refinements you can make on this to make it even cleaner. When we do functions, we'll get into it. And also make it so that whether they type yes or Y or capital Y to kind of clean it up. But this is fine for what we're doing in this course. Let's see. So I'm going to actually put in, because we already did a for loop. I'm going to put in a little bit of code in here, make like a little mini program to calculate maybe the sum of some numbers. So we're going to do this. We're going to get an int from user, and then we're going to add up all numbers from 1 to number provided by user. And then what we're going to do is display total, and then we're going to ask to do another. So this is often, when we're starting up a program, I often will write out my pseudocode essentially like this, and then I will start writing my code here, and I'll say cout, please enter a number. And then, probably need to put header to explain program. That'd probably be good here. And that'll just be a cout. Welcome to Super Adder 3000. This program adds all numbers from 1 to a number you pick. So that way our user knows what's going on. And I might put another ENDL here. I get a extra line. Please pick a number. And then I will cin into, and I need to input into something. So I'm going to have an int num to begin with, and then I'm going to cin into that num. And I'm going to try that. So I do that part first. And something happened. What happened? Why didn't it let me ask, do I want to do another?
Did it need to be getLine instead of CN?
Well, but we're inputting a number, an integer, so we have to CN to get into put an integer in. Otherwise, we'll get a string.
Okay. Because I'm like, I have no idea. Just guessing.
So one of the things we have to do is when we do a CN, it reads every. So the way the keyboard works, whenever we type, it puts it into the keyboard buffer. And then when we do a CN, it pulls out enough values to put into this. But because it's reading only enough to get an integer, it doesn't consume any carriage returns. And so what happened is when we got down to this get line, so we typed in, 1, 0, enter when we put in this number. The 1 and the 0 were put into num, but the enter still stayed in the keyboard buffer. And when we got down to this get line said, oh, there's already a carriage return in my keyboard buffer. I'm done. And so at that point, another was an empty string, and then it just stopped. To fix this, what you have to do is before you have to do a cn.ignore, and you have to do this after the last cn before every get line, before any get line. So since we could have multiple ones of this, I'm going to actually put the cn.ignore probably right here to make sure that any CNs will be, actually, in this case, I think we're only going to have one CN, so I'll just put it right here for now. Just make it obvious. So the cn.ignore will get rid of, will actually empty out the keyboard buffer before you do the get line. And now that I think about it, I kind of think this is actually a valid strategy like this. Just do the cn.ignore before your get line, just to make sure that the buffer's clear before you do your get line. And now if I run this, I put in 10, it says, do you want to do another? Put in 54, do another, 7. And so I know that now I'm getting my input, right? I'm not really doing anything with it, but I can get a number. It asks me if I want to do another, and I've got this tested. You see the advantage of kind of doing a little piece at a time? We know where the error is if we do it a little bit at a time. Does the cn.ignore part make sense?
Yeah.
Yes.
So always make sure if you have CNs and get lines that there's a cn.ignore between the last CN and each get line. So now I'm going to want to add up the numbers from 1 to that number. So so I'm going to have to iterate through all the numbers. Well, what I could do is I could use a for loop. And so in this case, I'm going to say for int I is equal to 0 or 1. Well, we could do 0 too, because 0 is not going to add any value. And we're going to say, while I is less than, and I want to add up all the numbers, including that number. So in this case, I kind of have to use a less than or equal. So actually, I guess we're going to go from 10 to that number. So it can be, all the numbers are less than num and num itself. And then my plus I. And so this will loop through all of the numbers. And then what I'm going to do is I need something to add up in. So I'm going to need a new variable I'm going to call total. And then total will equal total plus I. And what this will do is I is going to go through all the values from 1 to this number the user entered, and it's going to just keep adding them up until it gets total. And this is called accumulation, because we're adding what it had before plus the new thing, and then putting it back into total. Does that make sense?
Yes.
So this is a very common pattern. And the other thing we need to do is we need to start this off at something. Because otherwise, when we first hit this line, if there's nothing assigned here, it's going to confuse it. So we're going to start off with total at 0. So we're going to start with total at 0, and then we're going to keep accumulating numbers into I. And then when we're done, we'll say total is total. So now we have a for loop inside of a do while loop. Let me know when you're ready for me to continue.
I'm good.
I'm ready.
So I'm going to run this. No, it did not like. So if I get an error, oh, it's because I still have this one open. So let's take something simple. 3. 1 plus 2 plus 3 would be 6. So I put in 3, total is 6. Do another. Now, there's a couple things I don't like right now. It's working, but I need some carriage returns in the right spot. And I don't like, I want this, the user to type right next to that, and I want this another on another line. So what I'm going to do is, one is I'm going to put an ENDL here. And then I'm going to actually get rid of the NDL here. So 6, yes, do another. 5. 5 plus 4 is 9. Plus 6 would be 15. So does it appear to be working?
Yes.
So let's add another wrinkle. Let's say we want to add up all numbers from 1 to number provided by user, excluding numbers divisible by 3. How could we do that? Well, there's two ways you might think about this. One is you might be able to do something tricky in here to kind of only count and maybe thirds, or maybe something weird, but probably the easiest is put an if statement here. And so how can I tell if I is divisible by 3?
Use modulo or modulus, whatever you call it.
Yeah, so if I put I modulus 3 equals what? What's the modulus if something is divisible by 3? What's the remainder?
0.
Yeah, so if the remainder is 0, and you know what I'm going to do, because I don't really know, I'm just going to Maybe what I'm going to do is I'm going to see out just temporarily. I'm going to see out I, and then I'll do this. And I'll just see if it can figure out which ones are divisible by 3. So sometimes it's just easier. Just go ahead and, you know, we're going to do some extra prints and we're just going to see, hey, 1, 2, 3. Hey, it find out that was divisible by 3. 4, 5, 6. That's divisible by 3. What I really want to have happen, though, is maybe I want to set this up so it doesn't see out 3 and 6. How can I change this up so that it only displays the ones which are not divisible by 3?
Else statement.
Could use an else statement. Let's give that a try. And then maybe just put this in here. Well, now it's only showing me the ones that aren't divisible by 3 in the else statement. So that's working, right? Could I now get rid of this part here because I don't really need that, right?
Yeah.
So I'm going to get rid of this.
Could you also change the, instead of it being a double equals to a not equals?
Very good. So now I'm getting the numbers here, which are not divisible by 3, but you've jumped to the next thing we could do is, well, looks awkward. So I could negate this. And now if I run this and I put 6, 1, 2, 4, 5. So I don't want this to be done this way. Where do I want this to be now?
Inside the if statement.
Inside of the if block. Because right now, if I added 4, 5, 4, 2, and 1, that's actually what I would want. Does that make sense, Amy?
Yes.
Yeah. So now I'd say, okay, let's put this one in here. And maybe I will see out total as well. I'll do it this way. See out that and total so I can see it being built. Put a little delimiter in there. Let's see, I didn't get the total.
You ran the last successful build.
Oh, thank you. It's like got out of sequence. Okay, so 1 and 2, it became 3. Then we added 4, got 7. Then we got 5, got 12. Total is 12. So I think we kind of have it, don't we? So does it make sense how that all works?
Yes. If you had a minute, could you explain how, like, for example, on the another yes, no, what if I accidentally hit another key? It exits me out.
Yes. So you have to put in a Y to continue. Now, and then I was going to say is I would get rid of this because I don't really need it, and then I would clean it up. What we could do is we could do things like this actually. And we're not going to really understand this, why this works. Let's see. I think I can do it this way. We're going to need to learn a few more things to see how this works. 2, I can put in a Y. Now continue. 34, I can put a capital Y and it should work. 2, I should be able to put a Y yes. 54, I should be able to put a Y yes. So this is actually a way you could, we're going to take just the first element, which is a square brace 0, and then we're going to lowercase it. And this will take yes, any variation of yes. That's how you can make that make that cleaner.
So that's just, sorry, real quick. So that's just taking the index from the whatever character is in there and then throwing it to a lower value, right?
Yeah, because we're going to learn later that a string is really just a char array, and we're taking the first element of the char array.
Okay. Sorry, go ahead, Amy.
No, I was going to say later I want to figure out how to make it not exit me if I accidentally typed another number because I wasn't paying attention.
Yeah, and then it really makes it sense then to just kind of make a function that returns a Boolean and kind of build that up more. So when we ask me again about that, when we get into Booleans, and we'll turn that into helper function so that it doesn't get, because at a certain point you get so cluttered in here, it's hard, ideally the way I like my code to look is actually all this eventually becomes functions, and the program just looks like get number from user, display total, from number, and then if do another, loop back up. And this ends up turning into 3 lines. And we have everything abstracted away in a bunch of functions. But so you're all thinking along the right pathways to make this, because you want your instincts are correct. You want your code to be nice and clean and simple and kind of bulletproof from the user's perspective, where, this is annoying. They put in they get their value they want to go again, and they actually hit U, right? And it stops because U's right next to the Y. And so the other thing you could do is you could check against N and always loop back around, but then maybe they really wanted to stop. So, there's things you could do. You could do kind of a little while type statement here. You could embed this in a while and hold them hostage until they said yes or no. So, it would look something like this. It'd be like while, or do, again, because we wanted to always do this at least once. And then we would throw in here. And this is why I say it gets kind of messy. And so now I put this guard up here that forces them to have to put a Y or an N in, and it'll just keep looping around. But then if they don't know what's going on, the bad thing about this is if I run this one, they put in U. Okay. Yeah, I didn't do that. Well, oh, I need some knots. While not all of this. So I put in my U, And it's like, wait, I'm putting in the right thing, you know, and they don't know why. So now I got to build that into an if else, and it just becomes a mess here. So what I want to do is wait till I can do functions so I can put all that into a thing. So I actually prefer at this stage, just do a simple, do another.
So was this basically the video for the instructions for the loop demo, or do we need to go watch the video?
No, you can turn this one in for the loop demo. This is
Awesome.
all of that. I did a little extra.
Awesome, thank you. I'm sorry I've been late this week. I have been teaching till 4 o'clock, so.
Yeah, no, this course is actually it was set up as a distance learning. I just offer this doing the live classroom period because I was going to have to record these anyway, and this provides ability if you want to do it face to face, you know, through the web, you can. I actually in the future I'm going to try to get them to set my classes up so they're always what's called attend anywhere, or I think they're going to call them concurrent because attend anywhere used to include also in the classroom. And since we may not be doing that for a little bit, it really means you can either attend real time through the web, or you can, you know, watch the videos afterwards and do it kind of distance learning. And since I don't have, you know, classroom attendance, I just to substitute in for that, I just ask you to run through with the demos and then turn those in so I can see. And I'm not really grading those like, you know, super detailed. I'm just looking to see that you did them, as opposed to assignments, which are graded in detail. So this is really kind of extra for this class.
Thank you.
Cool. What do you teach?
Actually, I teach computer programming for artists.
Nice. Yeah, I'm in New Mexico Highlands. I just got my practicum right now is going to be to build some 3D models for museum, the Roswell Museum. So,
yeah, that is so cool. I'm so envious of that program.
Yeah.
When I started the MFA at UNM in experimental art technology, which I just finished, that's more what I wanted, but it wasn't. But you know, I finished anyway. But I'm envious. That sounds so cool.
Yeah, a little bit more, I think, in the programming area and in the coding side, and maybe a little less in the art side. You probably did they teach you like art classes too, like how to do drawings and stuff like that?
It was a lot of concept. I mean, honestly,
okay.
You know, I'd been teaching that content at high school, and so when I went to UNM, my coding knowledge is all in creative coding languages, and so they're not proper Java or proper C++, which is why I'm here.
Yeah.
But yeah, there really wasn't a lot of coding instruction in the program, which was unfortunate. But we're trying.
Oh, go ahead.
I was going to say we're trying to change that. Like I was been teaching the computer programming for artists class since I got there, and hopefully it'll keep going long term.
Oh, at UNM?
Yes.
Yeah, nice. Yeah, you should enjoy these classes. And I also do a game development course with Unity, and we get a little bit of Blender there. And
do you do that at CNM?
Yes.
Oh, I would love that. What's the code?
That's CIS1275, and it's taught usually in the spring. So if you do this one and do C, you need to have C# completed before that semester, then you can sign up for it. The prerequisite is C# 1280.
Do you think C# would be in the fall?
Yeah, I believe it's in the fall.
I've coded with Unity a little bit.
Yeah.
It's not, C#'s not that too different, but.
No, it's very similar to, well, I mean, basically it's basically Microsoft's answer to Java. But the basic code, just like Java, is very much, you know, the fundamentals like we're doing right now are going to be the same in Java and C#. Where it becomes a little different is when we start looking at classes. There's a lot of things that they do in C# to kind of protect you from making mistakes. They say, Bjarne Stroustrup used to say that C was the kind of language where you could shoot your foot off, and But C++, you could blow your whole leg off.
Oh, wow.
And mostly because of memory management. And languages like Java and C# put a lot of things in place to keep that from happening. And then so like the major game, but it's still fast, and both of them are still fast. So the major game engines are either in C# or in C++. Unity's in C#, and Unreal is in C++, and there's a few others out there that are in C++. So these languages all kind of build up to, and once you have the object-oriented programming piece to it, the framework for Unity starts making a lot more sense, especially understanding how that component model stuff works a little better. And there's a few more things you can do with it to organize your code that makes it a little cleaner than if you do like the tutorials out there, you can get things done, but sometimes it's kind of you run into these things. How do I make this happen? And then you see an example and it gets thoroughly confusing. The programming helps you understand what's going on with those more complex things.
That is my experience. What about the second C++ class? What does that go into?
So that is the Barbara Johnston was who is associate dean and who was an initial instructor. Kind of set up our initial programming model here, and we do like the C++ course first, which is kind of structural programming, which gets you through building functions. And then C++, ideally what happens is you get C++2 and then you go into C# and Java. You can actually go into both C# and Java, at the same time as you do C++2, but C++2 really is the one where you learn object-oriented programming from the ground up. And you can also go into C# as well. You get the same material, but all three of those languages, C++2, C#, and our Java course really are kind of the same course, but in different languages. And what that does is you get to see object-oriented programming from three different sides. By the time you get through that, usually you're so beat around the head and shoulders about how classes are made and structured that everything else becomes much easier after that.
What is C# used for besides Unity?
The other course I teach with it is CIS1275, which is web development, and that's kind of the bread and butter one for jobs around here. Most of the jobs for programmers tend to be in web development because that's how corporations kind of distribute their information, and so it is used for the server side piece of doing coding with a web, building a website that includes, a database backend, a server component, and then a client side component that runs in the browser. Now, up till now, the browser's typically been run with JavaScript and libraries like or frameworks, JavaScript frameworks like Angular and React. Microsoft is coming out with their own front end using WebAssembly that allows you to use C# both on the server side and on the front end. So I will probably be teaching Blazor, which is that C# front end, with the next iteration. And I think we're trying to find a way to get a React framework out there too. And between with those things, you kind of are really well placed for the different types of development out there. So does that kind of answer the question?
It does. I really appreciate that. I'm probably one of the, I don't know how many people love these online classes, but I couldn't do this if it weren't online. Cause I just can't have a Monday, Wednesday, Friday, whatever hour to go to CNN. So I'm hoping even after the pandemic is over that they'll still have some of these classes online. I hope.
Yeah, my intention is to have all my classes, my programming classes, be attend anywhere. So awesome. If we're back in the class, I like having some people in front of me sometimes because I can see their reaction. you like say something and it's out in the blind. It's like, okay, I think they got it. But when you see the confused look on someone's face in front of you, it helps to be able to say, oh, okay, they didn't get that. Let me try again. So maybe we'll get back to, maybe not this fall, but maybe the next spring. Maybe we'll be back in the classroom, and it'll be that mixed. I'll always try to keep it at that attend anywhere level. Might as well, since I've already got I'll have the material like by then.
That would be great. And so here's one voice voting for that.
Right on.
Yeah, because this was amazing for me to be able to take these classes. So I appreciate it.
Cool. Well, I need to get on to the next my Python class. So thank you very much, and I'll see you all again.
All right, sounds good.
Bye-bye.
Bye.